In today's lesson, we're going to move on and look at the water cycle again. We looked about the importance of the water cycle, but now we're going to look at those stores and flows in the water cycle at both a global and local level. So this is part of 1.A for the OCR A level, and it's this section about water cycling between open and closed systems. So just to look at a global scale again, remind ourselves what we learned before. The Earth is a closed system in terms of water. That means energy can cross the boundary of the system, but essentially there's a finite amount of water on Earth. No water is lost from Earth or gained from Earth. So we have a closed system. The analogy I used before was that it was like a pan of water on a stove, and you could say you had a see-through lid. That means heat could get in through that see-through lid, but nothing's going to escape from the parameters of that pot of water. So because water isn't gained or lost, it must be stored in different places. So stores of water is where water is kept in this global system. So the place that stores the most water is the oceans, 97%. And that takes up obviously most of the water. Next is glaciers, then groundwater, so aquifers, so under the ground, permeable rocks which hold water, lakes, soils, atmospheres, rivers, and biospheres. You'll see that rivers, we think of them as obvious stores of water, are actually quite low in the percentage of the overall amount of water on Earth that it stores. What's also interesting is the fact that most of the water on Earth is saline, it's salty, and that even though there's lots of categories, fresh water is actually a tiny proportion of the amount of water that's actually stored on Earth, and of that, about 60 to 70% of it will actually be just stored in those polar ice caps and glaciers. Here's a more simplified version of the water cycle. These areas, the oceans, atmosphere and land here, these are our stores. So this is what we've just looked at. And these red lines in between are the flows, or what we might call processes. So what we can see here, oceans again store the most water. We already knew that. But in terms of the flows, evaporation and precipitation are the major flows between the different stores. We also can notice that the atmosphere actually, despite taking up quite a large part of Earth, actually stores very little water. And this is because the water is cycled really quickly from the atmosphere back into another store. So we say it has a low residency time. It's not kept in the atmosphere for very long. They say the average water molecule actually has a residency time of about 9 days. So knowing the stores and the flows is really important to our overall understanding of the global system. And later on, we're going to get you to look over the definitions of what all of these terms like evapotranspiration and groundwater flow all mean. So here is slightly scaled down. We could say that this is the hydrological cycle, but these are all the stores and processes that are going on in the water cycle. And now we're going to take it down from that global scale down to a drainage basin scale. We're going to look at it, which is an open system. That means not only energy can pass through the boundary, but also we can look at it from the fact that matter can pass over the boundary of one system into another. We looked at the Amazon briefly in one of the previous lessons. So here is a drainage basin. This is a fjord in Norway. And I want to think, if this was our drainage basin, this was our local kind of system, what processes would we find happening in this drainage basin? I want us to think in terms of what inputs we might have into this drainage basin, what processes, what outputs. Remember, this is just a localized scale, so there would be drainage basins next to this one, and what would go into those from this drainage basin, and what kind of stores we might have in this drainage basin. So what I'm going to get you to do now is actually to stop the video and think about those four categories: inputs, processes, outputs and stores, and make 4 columns and just see what you can remember from your GCSEs and see how many of them you can actually name. Okay, hopefully you've taken a few minutes to have a go at that. Think about the processes, stores and inputs that you've got. Here's some of the ones that you should have come up with, hopefully. Precipitation is an obvious input, but also I said energy and matter. So energy from the sun. Sun is going to be an important input into our system in this drainage basin. Processes, there's quite a lot of them obviously going on. Evaporation, evapotranspiration, percolation and infiltration are happening under the ground, so it might not be that obvious from looking at the picture, but obviously these processes go on above the ground and under the ground. Stream flow, we could see that very clearly from the fjord. The water would flow in the fjord into rivers and beyond. Storage, lots of different examples here you could have had. You could have actually had the fjord, which would count as a river or lake, but also, again, above the ground, clouds and atmosphere. On the ground, things like leaves and the trees would actually store water, including ice, glaciers and snow. An ocean I've put, but you could have put kind of the fjord or the lake. And also below the ground, aquifers, which is that groundwater store. And then outputs, I said, rivers flowing out of this drainage basin into the others. Also, humans can extract water from here. So we can take water out of the system. You could take it from that fjord and literally drive it to another area. We could extract it through pipes and pump it to a whole new drainage basin. We can take it out of this local system and put it somewhere else. And also, as I said, under the ground, groundwater flow is just one example, but we've got water potentially moving across that boundary of the drainage basin into another area. So hopefully this is quite a good overview of both the kind of water cycle on an open system, so we're looking at it from the drainage basin level, but we also looked what's happening in that closed system and the flows between the stores on the larger global scale.